All right, let me share my screen. If you can see my screen, say yes in the chat. If you cannot, say no. So can everybody see my screen? Yes, all right, very good. Let's begin. So today is lesson 3 of functions slash coordinate plane. And first we'll go over our homework questions, and then we'll review slope, and then we'll go over graphing forms. All right, so let's do this one first. All right, let's look at our answers. So the x-intercept, William says the x-intercept is negative 53/3, and the y-intercept is 53/9. All right, I think Elaine says, yeah.
Or well, you can say
Mine says it's -7 and 35 over 9. So we have some different answers. All right. What were you going to say, William?
Oh, I was gonna say that I changed it. The x-intercept is -53 over 5.
Oh, all right. All right, so let's look at this. So what we need to do, what do we need to do to find the y-intercept and x-intercept? So, all right, so who can volunteer to do this one? Any volunteers? Okay, William, how do we do this one? To find the
So
x-intercept.
to find the x-intercept, we have to pretend that y equals to 0. So it is -6 equals to 5x over 3 plus 35 over 3.
Good. And
And then after that, oh wait. After that, we divide, we multiply everything by 3, so it's -18 equals 5x plus 35. Then we move the 35 to the other side, so it's x equals -53 over 5.
all right, very good. So what we need to do is, of course, make y 0, right? So from this, we can get that x is equal to -53 over 5, and that's our x-intercept. So similarly, we can solve the y-intercept. All right, continue, William.
So the y-intercept, for the y-intercept, we have to pretend that x is 0, so 3y minus 6 equals 5/3 times 0 plus 7. So that just means 3y equals 3y minus 6 equals to 35 over 3. And then after that, move the 6 to the other side. So 3y equals to 53 over 3. And then we move the 3 to the other side. So y equals to 53 over 9.
All right, very good, very good. So the x and y intercepts are -553 over 5, and y is equal to 53 over 9. Now, the thing is, x and y intercepts are very important because you can use them to graph. Even though we do not know how to graph this formula for the line, this is written sort of in point slope form, which we have not learned yet, but we know the x and y intercepts. So all we need to do is to graph those 2 points and draw a line between them. Because a line always forms between 2 points. All you need is 2 points to form a line, and you know that the x and y intercepts are part of this function. So all you need is the x and y intercepts, and then you draw a line through that, and that's the graph. That's why they're very important. And when you learn later, the x-intercepts can actually be solutions for, quadratic equations, those kind of functions. All right, but we'll learn that later. And you learn how very important the x-intercepts and the y-intercepts are. All right, so now let's do this one. This one with a picture. All right, let's go over this one. So let's look at our answers here. We have 4. The slope is 4. All right. Oh, Isabella, how many classes are left? All right, we still have a lot of classes because this is only, I think, this is only like the 4th unit. I think, yeah. So it's only the 4th unit, so we still have like a lot of units to go through before we finish algebra. Okay, so let's look at this question. A function includes the points displayed in the table shown and find the slope of the function. This is quite easy. So what you need to do is you need to find the common difference between these. All right, these points. The common difference in the x is 1, and the common difference in the y is 4. And since slope is basically change in y over change in x, it's going to be 4. The slope is 4. Let's do this one. All right, let's go over this one. All right, so this is so a lot of people say -3, and that's correct. Very good. So basically, the line is parallel to another line, then they have the same slope. You can see from y-intercept form that the slope is -3. So therefore, it's -3. Okay, let's go on to basic vocabulary. We're gonna just a review. All right. So for the x-intercept, what does that mean? That is when the graph intersects the x-axis, all right? And you see here, it's like this. This is where it intersects the x-axis. And the y-intercept is when the graph intersects the y-axis. All right. So you see here we have the same line, except now the y-intercept is here. All right, so who can tell me something that happens with the y-coordinate when it's when it touches the x-axis? All right, how about Kaylee? What was that?
The x becomes 0. No, the y. So when it's the y-intercept, the y-axis becomes 0.
Could you repeat that? Sorry, I didn't hear clearly.
When it's a y-intercept, the y-axis becomes 0.
So when it's the y-intercept, all right, I think you're getting it mixed up a little bit. So when it's the y-intercept, what happens to the x-coordinate? It's not the y-coordinate that turns into 0, it's the x-coordinate, right? Because it touches the y-axis. So therefore, x has to be 0, right? Same with the x-intercept. If the x is on the x-axis, then the y has to be 0, right? The y-coordinate equals 0, and the x-coordinate equals 0. So do you understand now? All right. Let's move on to the review of the slope. All right. So it's basically delta y over delta x, which means change in x. This change in y over the change in x. All right. So y comes first on the top, and then change in x. And you can some people say it's rise over run, right? It's rise over run. All right. And so some things about the slope, right? So some special properties. So some properties. All right. So if the slope of two lines is the same, they are what? They are parallel, right? However, if the slope of two lines the slopes of two lines are opposite reciprocal, then they are perpendicular. All right, so remember that if the slope is the same, then those two lines are parallel. If those two lines are perpendicular, the slope is opposite reciprocal. So what does that mean? Opposite reciprocal means, i.e., the flip sign, and take the reciprocal. So for example, if you have 1/3, then it's going to become -3, right? You flip the sign, which is from positive to negative, and then you take the reciprocal, flipping the numerator and the denominator. All right. And also about lines. A lot of information on the slide. All right. About lines. All right. They can be graphed. They can be formed or graphed with only 2 points. All right, so that's a very key point. All right, so the point of the like slope-intercept form or some other forms like the point self form general form is to just give you 2 points, make it easier to graph. Right, so the slope-intercept form, well, you know the y-intercept and slope, right? So if you know the y-intercept, that's already 1 point. And then you can use the slope to find another point, right? And you can graph it very easily. So that's why when you're graphing something, right, graphing a line or something like that, usually go to slope-intercept form because it's very easy to graph. All right. And also about lines, there is domain is infinity to infinity, right? There are no restrictions. If you look at the slope-intercept form, there are no restrictions at all. And of course, lines go forever. All right. If a line or a so-called line has endpoints, and then it's just a line segment. So lines, they go forever, right? Okay. So now that we've been talking about slope-intercept form, let's go review slope-intercept form. All right, so it's y is equal to mx plus b. In this case, m is the slope. All right, m is the slope. M is always the slope when we're talking. Let's do this. Note M always denotes slope when we're studying linear equations. All right, so when we're studying about linear equations, M always denotes the slope, right? In other areas of mathematics or other theorems, M might denote something else, right? Totally something else. But M, when we're talking about like linear equations, this kind of slope-intercept form, it always means the slope, all right? So when We're giving something like that, m is equal to what? Then you know that's the slope. So let's kind of dissect this slope-intercept form a bit. So m, of course, we know is the slope. And b, very important, is the y-intercept. All right, so that's crucial to when we're graphing it. All right, so you can see why it's called the slope-intercept form. Right, it gives you an intercept and a slope. Right, so it's incredibly easy to graph. So the next thing is point slope form. Y minus y1 is equal to m times the quantity of x minus x1. All right, so x1, y1 is any point on the function. And then x and y are general points. For example, in slope-intercept form, these are just there. They're general points. They're variables that can change. But x1, y1, they're actual real numbers, while x and y are just variables. Of course, if we dissect this, m, of course, is the slope, right? So that's about it for point slope form. All right, and we'll see and then we'll talk about how to graph all these forms later in like the next few slides, right?
I have a question. What does the x stand for in that equation?
What?
What does the x stand for in that equation?
What does the x stand for?
Yeah.
The x is just a variable, right? X, like so you can see that x is the input and y is the output, right? So they're just variables. They can change with the function, right? If you look at like a line like this, x and y change with every point, but y1 and x1 are actually a fixed point on the function. We'll talk more about that. You'll understand more after I teach you how to graph it. All right? Do you understand now?
Yeah. Yes, I do. Wait, am I muted?
No, you're not muted.
Oh, okay, yeah, I do.
All right, thanks. Okay, so now let's go on to our final form, the standard / the general form, right? So this is probably one that you're not gonna see that often, all right? But it's still there, and it has its benefits, all right? So ax plus by plus is equal to c, all right? So that's the thing is, it does not give you the slope anymore, right? It does not give you the slope. Okay, so previously, let's observe. All right, previously it gave you a point. All right, slope-intercept form. What does that give you? The y-intercept. That's 1 point, and then it gives you a slope. That's kind of similar to point slope form. Point slope form gives you a fixed point x1, y1, and then also gives you the slope. Right. However, for the standard / the general form, you don't. Right. You don't get the slope. In this case, A, B, and C are fixed real numbers. Right? They're fixed real numbers. So you might encounter something like 3x plus 2y is equal to 10. Right? So does anybody know what is the advantage of this? All right, so now let's look back at slope-intercept form. What is the advantage? It gives you y-intercept and slope. Straight out, it's right there. It's extremely easy to graph. Now let's look at the advantage of the point slope. It's if you look at a line, find any point on there, it's extremely easy to acquire point slope form. All you need is 2 points, find the slope of those, and use 1 point to acquire this point slope form. Our third and final form, what is the advantage of this? It doesn't give you slope. It doesn't even give you a point, or not that you think so, right? If you look at this, like for example, 3x plus 2y is equal to 10, it doesn't just straight out give you a point, right? Unlike point slope form, or unlike slope intercept form. So let's brainstorm, let's observe this one. Why is it, what are the advantages of this one? All right, so let's see, who can tell me something about this form that you observe about it, right? What makes it different from the others, right? What's so good about this form? Okay, how about who volunteers? All right, do we have any volunteers? All right, how about Sibo? Could you answer this one? There's no right or wrong answer about this one. Just make some observations about this form. It's certainly very different from the other ones, right?
I have no idea what to say.
You have no idea? All right, that's fine. All right, let me tell you. So the thing is, x and y are both multiplied by a real number. So what happens if you make one of them 0? Let's look at this. Make x 0. Then a and x are completely vanished, right? Then you're left with by is equal to c. Therefore, you see that the y-intercept right? A times 0 plus by is equal to c. You can get that very quickly, right? Y is equal to b over c. Likewise, you can get the x-intercept. The thing that is so different about this form is because it does not give you just 1 point and a slope. It gives you 2 points, the y-intercept and the x-intercept. You see that x is equal to c over a. All right, now that you have 2 points, the y-intercept and the x-intercept, which are incredibly easy to acquire, you can graph the line quite easily. However, now that I've explained this, who can find a very not so good part about this, right? See, when you're given point slope form, it's usually a very good point. Let's say 2, 4, and the slope is like 3, right? That's a pretty nice point, and you get a pretty good equation. Even if you're given slope-intercept form, it's a pretty good y-intercept, right? Let's say 5, and the slope is 4, right? It's pretty nice. However, what if you end up if you go in the standard form and you end up with something like this, right? 3x minus 6y is equal to 19. This is quite a disaster, right? Because if you try to find the y-intercept, it's going to be y is equal to negative 19 over 6. No, x-intercept, right? The x-intercept is going to be 19 over 3. You see, it's not an integer, so it's quite hard to graph from just the y-intercept and the x-intercept. Of course, if these are all quite good numbers, pretty good numbers, then you can graph it pretty easily. But the downside of this is usually it's not very good numbers, right? They don't just straight out give you such a good number equation with such good numbers. When you get into higher mathematical topics, then usually we're working with pretty ugly numbers, right? So that's the downside. The y-intercept and the x-intercept might not always be good numbers to work with, right? So now we finally come here, how to graph all of these. How do you graph all of these? All right, so this one is actually, now that I've explained all these forms, it's actually pretty easy to think about how to graph them. All right, so let's have these up for reference. All right. So let's do this. Okay, so who can help me with how to graph? Let's actually make three coordinate planes. All right. So how do you graph slope-intercept form? All right. The first thing you want to do is you need to find B, all right, which is obviously the y-intercept. Now it doesn't have to be here; it could be a negative or anything. We're just gonna use this as a reference point. Now, let's say let m be equal to, let's say, let's see, what are some variables that we haven't used yet? N over t. How about that? Let's make it n over t. All right, yeah. All right, so make it n over t. And these are just arbitrary variables, right? N over t. Using the slope, you can find another point, right? Which is just, okay, it's just going to see from the y-intercept, right? You can add n to it. So it's going to be t, and let's say b plus n, right? So from using the slope, you can actually you can find another point on the function, right? So let's substitute this with real numbers. And of course, after you found another point, you can just draw a straight line through it, and that's your line, right? All you need is 2 points. All right, so let's see. Let's try this out. Y is equal to 2 over 3 x minus 3. All right, so -3 is our little point here, the y-intercept, right? And then you can use, all right, you can use the slope to find that out, find another point, right? So let's just add 2, right? Rise, that's the y, and then overrun. So add 3, right, like this. Right. Or if you want to, you could also go the other way, right? Also, since 2 over 3 is the same as -2 over -3, right? So subtract 2, subtract 3, something like this, and you can see that it's going to be on the line, right? See, my coordinate plane is very badly drawn. Hopefully you can do better. But you can see that they're kind of on the line, even though this is not a straight line. All right, to fix this. And kind of something like that, right? So remember, you can go both ways. You can even plot through points if you wanted to make sure, right? Okay, so that's very easy to graph, right? How about y minus y1 equals to m times x minus x1. All right, so you can see that you're just gonna, it already gives you, straight out gives you a point, right? Already straight out gives you a point. So what you can do is the x1, y1 already gives you out a point. And you also have the m, right? So we're still letting m be n over t. Then you can find another point, right? Let's say another point like this, draw a line through it using the slope. And this can just be like x1 plus t y1 plus n, right? Or the other way around, x1 minus t, y1 minus n. So you can kind of use the slope to find another point on the function. Now, of course, we know that standard form, all right, you can find the x-intercept. X-intercept is just going to be c over a. Y-intercept is going to be c over b, right? Draw a line through it, like that. You don't even need the slope, right? All right, so that's how you graph all three types. All right, all you need is 2 points. All right, so and you have more than enough information to get 2 points. Right? Okay, let's go over our practice problems. And since you guys need to graph these, I'm only gonna give you 3 questions, both in the practice problem section and the homework. Right, so whenever something involves like graphing or something, it's going to take more time, right? So I'm only going to give you three questions, and plus, you know, it's a summer, so I'm more lenient, right?
I have a question. I didn't really like understand the y minus y1 equals to m x minus x1. I didn't really understand that.
Where do you don't understand?
Like I didn't understand how do you like what do you substitute y for?
So oh, I'll give you an example. So look at this.
Yeah?
This is
Yeah.
this is this is x1, right? So they're actually substituted for real numbers, right? But y, yeah, like that. So they're not actually like
Oh, okay. Yeah. And then solve the equation.
yeah.
Okay.
All right, so let's do the first
Yeah.
one. This one, graph it real quick.
What are you watching, Sophie?
All right, so I hope everybody had a chance to do that. Let's graph this one. So we know that our y-intercept is -3. And from the slope, right, you get another point. So what we need to do is the slope is 7/1, right? So let's go up by 7. 1, 2, 3, 4, 5, 6, 7, and go to the right by 1. So this is a very steep line. All right, something like that. Okay, let's graph the next one. All right, let's graph this one. So this one, you see that the point is going to be 2, -3. Now, why is it -3? Right, because the formula is y minus y1. So if it's subtracting a negative number, then it's a plus, right? So if you see a plus sign, it's actually a negative coordinate, right? So it's 2, -3. That's the point given to us. And right here, and then we use the slope, go up by 3, and go to the right by 2, you get something like this. That's okay, that is our line. All right, third one. All right, let's graph this one. So from here, you can see that we can find the y and x-intercepts very easily. So the x-intercept is equal to 2. And the y-intercept is -6. And just draw a line through them and you're done. All right, so did everybody understand those practice problems? All right, no questions? Okay, that's the end of our class. Thank you for listening. I'll see you next week.
Bye.
You see you next
Bye.